Hi everyone, this is coming to you from Education for All. Today we are going to look at exact values of some trigonometrical ratios. We're still on the topic trigonometry. So we are going to look at two triangles. Two different triangles. One is an equilateral triangle, in which case all the sides, the three sides of the triangle are equal. So that means the three angles of the sides are also equal. That's why they call it equilateral triangle. Then we shall be looking at an isosceles triangle. It's another triangle wherein the two sides of the triangle are equal, meaning the two angles on those sides must also be equal. So, if we have an equilateral triangle, we are assuming that all these sides are of the same length. A, B, and C. So because we want to calculate trigonometric functions here, we need to have something like perpendicular line. This perpendicular line, it can also be drawn from here to here. All what we want to do is to divide this baseline into two equal halves. So once we get this perpendicular line drawn, we can now give some measurements and angles to the sides of this triangle. So if we say this is 1 unit, this is 1 unit, so this makes 2 units. Let's put n here. 2 units. But we claim that all the sides are equal. So if this is 2 units, this also must be 2 units, this also must be 2 units. So this is a triangle. And mind you, the angles in a triangle, the sum of the angles in a triangle, they always make up 180 degrees. And if all these sides are equal, it means the angles at the corners where these sides intersect, they are all equal. The angle you have here, the same as the one here, the same as that one you have here. So if the sum is 180 degrees, it means we have 60 degrees here and 60 degrees here. The whole of this is 60 degrees, but because we have drawn a perpendicular line, so it means this one now is going to be 30 degrees, and this one here will also be 30 degrees. What we are trying to do here, as the heading indicates, exact values of trigonometrical ratios. We want to find values of trigonometrical ratios of sine, the cosine, and the tangent of what? Of 30, 60 degrees. 30, 60 degrees. We need 45 degrees as well, and the 90 degrees, of course. But because this is an isosceles triangle, you cannot get a 45 degrees angle here. That's why we're going to look, sorry, an equilateral triangle. That's why we're going to look at the next triangle, which is an isosceles triangle wherein the two sides are equal. This and this will be equal, and then if this is 90 degrees, and again the sum of these angles inside this triangle must be 180 degrees. So if this is 90 degrees and this side is equal to this side, it means this one here must be 45 degrees and this is 45 degrees. 45, 45, 90 plus 90, 180. So when we look at this triangle, then we'll be able to have our 45 degrees calculation from this one here. But for now, we'll concentrate on this one. So we want to find the sine of 30 degrees. Sine 30. What is sine 30? The sine of 30 degrees, this is equals to the opposite, which you know, of course, over the hypotenuse of the triangle. So if you are looking at this one here, sine of 30 is, we'll say, is the opposite. This angle here, this side is opposite of it. So which means we'll have 1 unit all over the hypotenuse. What is hypotenuse? It's 2. So therefore, sine 30 is 1/2, 0.5. So what about cosine of 30 degrees? We know it's the adjacent side all over the hypotenuse. So I'm still looking at this 30 here. So the cosine, we say, is the adjacent to the angle. What is the adjacent to the angle? We look at Cn. Cn all over the hypotenuse, 2. What is Cn? So now we need to calculate the value of Cn. So what is Cn? If we look at this triangle here, this is 90, this is 30 degrees, this is 60 degrees, we know. And we say this is our C, this is our N, and this is our I. This is 2, and we say this is 1. We want to find the value of this length here, Cn. This is a right angle triangle. We can use hypotenuse Pythagoras theorem to solve this one. And Pythagoras theorem tells us that the longest side, which is the hypotenuse, 2 squared is equals to the sum of the remaining side, the squares of the sum of the remaining sides, which is an squared, which is 1 squared, which is just 1, plus cn squared. So we know now 2 squared minus 1 squared equals cn squared. So this is 4 minus 1 equals cn squared. So this is 3 equals cn squared. 1 cn, not cn. So therefore, cn is equals to the square root of 3, so root 3. So in fact, this side here gives us root 3. By Pythagoras, this is roots of 3. Right? So if that is the case, we now have cn, which is root 3 all over 2. So that is the cosine of the value of cos 30. So what about tan 30? Let me don't put fractions. Let me just do this one. What about tangent of 30 degrees? We all know tan is the opposite all over adjacent. So the opposite, which is 1, all over the adjacent, which is root of 3. Alternatively, you know tangent tan x is equals sine of x all over the cosine of x. So if you want tan 30, you can simply say tan 30 is equals to sine of 30 degrees all over the cosine of 30 degrees. And we already found the values of sine 30 and cos 30. Sine 30 we said is 1/2 divided by cosine of 30 is √3 all over 2. And you know this, the denominators will cancel, innit? So you will have 1 all over √3. So this is a root, square root of 3. If you don't sort SURDS, we want to conjugate this sort. So what we do here, we multiply top and bottom by √3. So we'll now have 1 all over √3 times √3. So we should multiply here also by √3. When this cancel, you still have your 1 over √3. But √3 times √3, this will give us 3. So you now have √3 all over 3. They want you to leave the answer like this, not 1 over √3. They want it this way. So this, now let's do the sine, the cosine of 60. We've done sine. That will be in the next video. Thank you for watching. Bye bye.